Okay, I think we are online. Welcome everyone. Today we are again in Microsoft Office streaming. Today is Saturday instead of Sunday because why not? Let me decrease a bit the sound. Boom, boom. Okay, I hope you can hear me well. So good. Yeah. So today I chose to stream on Saturday instead of Sunday. Let's see how it is going, how it will be going. Just to check. Yeah, just to check what would be the difference. Anyway, today our agenda is pretty much the same. We have a couple of Q&As. Then we're gonna do LeetCode. Today we have a bunch of questions about the binary search tree. Then we're gonna go for the system design. As you remember last time, we started with the designing the URL shortener, but apparently we saw that we have distributed monotonically increasing ID generation, which we're gonna design today. And also subsequently we're gonna implement it as well. So yeah, that's it. And last thing we're gonna do is, yeah, you remember I pasted a couple of outsource questions that I've been asked many times during my previous interviews, so we're gonna review them as well. Okay, I think we can start. However, not that many people are watching us right now, so let's see. So regarding the Q&A, I've been asked by one of the guys, I think in Telegram. He's just starting. He did some front end, and now he's choosing between front end and back end. And for back end, what is better to learn, and all these kind of questions. Yeah, it's a bit hard when you're just joining because you don't know much about how things work. All right, so let me answer this question. First of all, it depends what you're gonna do, and it depends on your needs. If you want to get the job as fast as possible, then I would say just go check market. Whenever you see more positions for backend, whatever the language is, choose this language and learn it. It won't be throwaway work, because backend does not only imply one language. So language is like maybe, I don't know, 50% of the whole backend scene. So apart from that, for backend you have networks. So networks is language agnostic. You have databases, storages, it's language agnostic. You have deployment, scaling, reliability, scalability, also consistency. These things are also language agnostic. So like whatever you choose, you anyway will end up learning pretty much same stuff. So for backend, you for sure will learn storages, as I said already, like how to deploy, how to handle concurrent requests, so concurrency as well. It will depend on your language, but in general, concurrency as a mechanism, it's pretty much same everywhere, right? Just language is abstraction over operating system, right? Anyway, yeah, so it will not be throwaway work. If you want to get job as fast as possible, just do. Sorry, I just need to check whether chat is available. It should be. Yes, it is available. Good. Just to make sure. So yeah, if you want to get job as fast as possible, just go with market. Whenever you see more positions, just learn this backend language. If it will change not that big of a deal. You can switch most probably. Then the question was also about the Java, but I would strongly not recommend Java. I personally don't like Java as a thing. Sorry, all Java devs, sorry for that, but yeah, I really don't like it, especially comparing to .NET. Basically, if we compare, yeah, by the job market, Java might be a bit dominating on the market. However, I quite questioning that, because actually .NET right now is better pretty much in all senses as a backend language comparing to Java. It has better thread synchronization model. It has better like out of the box async await. It has better performance. It has more, I would say, mechanism syntax sugars for easier and better the development. And as for now, I think maybe 10 years already, .NET is cross-platform. So there is nothing Java beats C# and .NET at the moment, unfortunately, or fortunately, I don't know. Regarding comparing like what to choose as a backend language, frankly, I can speak only of the languages I used, right? And also I'm pretty biased because my main is .NET, so I would recommend .NET like pretty much almost in every possible situation, right? So I can speak about Node.js as a backend pass, Python as a backend pass, Java as a backend pass, because I tried Java as well in like commercial development, and .NET. Like with regards on like Rust, C++, C, Go, I cannot say much because I never use these languages, right? So this one you should choose on your own. I'm not sure how to answer this question. With regards to .NET and .NET, Java, Node.js, and Python, what I mostly liked is Node.js and .NET. Java I didn't like because usually whatever like it was available in .NET, in Java it is not implemented, so I pretty much didn't like it. For the Python, I hate this experience as well, and I don't recommend choose Python as a backend language. It has very bad and poor thread model. It has very bad and poor async model as well, and it has pretty bad, I would say, package managing model, because .NET has NuGet, Node.js has npm, and Python has this PIP, which is like their native package manager. I don't like it. I struggled a lot with this because I had startup related to AI, and all cool libraries related to AI are unfortunately on Python, so you end up writing your backend on Python as well, unfortunately. So yeah, I didn't like the experience. I wouldn't recommend this as well. So these are my thoughts. If you want to choose, like, not to get the job as fast as possible, but to get as better dev experience as possible, I would recommend .NET and Node.js. How long it take you to get first job in it, and when it was? It was some random question from the TikTok. So I actually don't really remember, but I think at 11th grade in school I started learning HTML and CSS because I wanted to do my personal website. Then I switched to PHP, and I think for 1 year during my transition from school and university I was learning PHP. Then I switched to courses that were in .NET, so I switched to .NET completely from PHP. And starting from that point, my main was .NET, since my first job after Kickout Bootcamp was in .NET. So pretty much I would say maybe 1.5 to 2 years, like overall, starting from complete zero when I just didn't know even what is HTML and CSS to junior position. It took me around 2 years, kinda. So that was very good. That was very good question. So lately on YouTube and I think TikTok, I posted this video about seniors at 20. So actually, most probably you heard about these guys, especially if you're working in outsource. because I was one of the guys. So the thing is that in outsourced companies, the title inflation, I would say, is pretty big, and there are a lot of high title for young and experienced guys. And at my 20, I also got senior title at EPAM, just because outsourced companies have very bad interview interview process, I would say. Mostly the interview process was consisting of asking me questions like this for 2.5 hours. No problems, no system design, no LeetCode, nothing completely, just knowledge-based check, which you can pretty much memorize and get whatever title you want. So I had pretty good offers. Actually, I had offers that were better than my current Microsoft offer, compensation-wise. So, and the question was like, but is this interview process worse than LeetCode and system design, like in regular big tech? So this is pretty interesting trade-off, because, yeah, I don't know. For me personally, the easier one is knowledge-based interview, because I already learned a lot of these questions, and it's not hard to learn them, and you feel like, yeah, I know this and that. Cool, I can pass this interview. You feel great. But when I tried LeetCode and system design approach, like big tech companies, it was awful, because LeetCode I couldn't do at all. So it took me pretty much 2 months to get prepared for Microsoft, and I wasn't prepared very well. So most probably I would be rejected by Google, Amazon, and other companies, right? So I just got lucky. So LeetCode is pretty hard. Yeah, it has nothing in common with what you're gonna do in your real job responsibilities. That's true. That's true. Whenever I passed after interview at Microsoft, I was not solving LeetCode type of problems. I was not using data structures like hash maps, binary search tree, and these things. That's true. That's for sure true. But I think if there would be any better way to interview and to kick out bad candidates for big tech, most probably big tech would use it, because on their scale it would save a lot of money. But most probably there is no such way. It's kinda, you can imagine it like exam. You're preparing, yes. Interview skill and your actual skill are different skills completely. But unfortunately, whatever you think about that, you can just accept it. You cannot change the interview process, right? You can just bitching about that. That's true. You can do it, but you'll not be successful in interviews if you're just bitching. So I chose different direction. I just accepted it. Yeah, I didn't like LeetCode much, but I just accepted that it is required, and now I'm doing LeetCode whatever, because I know it's my interview skill, and my salary basically depends on my LeetCode skill. Sorry, but that's true. My salary does not depend how well I'm performing at Microsoft right now, to be honest. Like only promo, yeah, it kinda makes subtle difference, but not that much. And for system design, for example, and OP questions, I think they are very good. Even more, I think they should be asked in pretty much in all companies, especially for positions like seniors. You should be able to design like basic problems that you're asked, like URL shorteners, like some basic thing. Yeah, maybe for big scale, your solution would not be ideal, and this is acceptable, but to design at least basic stuff that's gonna work on some like decent load, you should be able to do it if you're a senior. I'm sorry, you should be able to do that. So actually I would prefer, and also another good point about this, that actually when you're getting in big tech, you know what to expect. So you know it's gonna be LeetCode. So just learn these 5, 6, like 7, 8, I don't know how many patterns for the LeetCode to be able to solve pretty much any possible medium question at LeetCode in reasonable time. You will pass it. Yeah, you can be unlucky with interviewers, but eventually you will pass it. It's not something that you would not expect, right? Same applies for system design and OP, and same applies for behavioral. You know what type of questions you're gonna be asked, right? And if you know that, it's easier to get prepared. Whereas, in the other hand, like these type of questions, every single possible interview that I was getting, it had some additional questions that I never faced, and I have no idea, because you either know it or you don't know it. Like, you cannot come up with some answer. Like, if you don't know the difference between this, like, what are you gonna tell to the interviewer? Yeah, you don't know it, and he sets the like red checkbox in front of some domain area, and then based on it, you might not pass the interview, right? So for me, actually, easier and more beneficial approach would be this one, but I think that this is not the greatest way to interview the candidates. Personally, if I run my own company, I wouldn't use this type of questions in my interview, because it does not show your skill and how you're gonna perform at all. Because yeah, EPAM rated me as a senior, but then reality check came and I was rated as a junior at Microsoft, and I accepted I was really junior back then. I'm sorry, but I was junior. Like, and the fact that I knew all answers to these questions, it does not make me senior. Sorry, I cannot solve problems, like real problems. So that's it. I would actually prefer most probably this type of questions, and especially be prepared to this type of questions. Okay, I think Sam is asking, what projects would you recommend for a web dev, software engineering, software dev, personal portfolio for job marketability? I would not say you need projects. If you already had experience, just focus on your working experience. Most probably you will be asked, what did you do during your work commercial experience? Find good showcase in your work experience. If you have time for side projects, maybe focus on some additional incentive. What can you improve in your current position, and do that, because interviewers are mostly interested in your commercial experience. Or maybe if it's not commercial, then interviewers are interested in your, I don't know, maybe open source contribution, but I doubt you are doing it. I doubt many people doing open source contributions. So yeah, better to focus on working commercial experience. But if you don't have working experience yet, well, you can implement some, like if it's for backend, right? For web includes also front-end and backend. I'm not sure what you are mainly focused on, but for projects for backend, implement some basic route, use some storage, use caching. On top of that, I don't know, create some two services that communicate between each other through the HTTP and async way, like queue. Yeah, again, storage, some caching, and deploy it somewhere. So create Docker, deploy it, make it easily runnable locally with Docker, and deploy it to some cloud, I don't know, maybe VPS. So we have this experience with CI/CD, maybe configure CI/CD for that. Like, this pretty much demonstrates all your skill set that you need for backend, right? You're working with storages, you're working with caches, you're working with queues. So all infra tools, not all, but many infra tools you cover already. You can do HTTP requests, they are working, you can deploy your code. Well, pretty much it's junior already. Like, I would hire this guy as junior if you can do this. Yeah, okay, I think we're done with questions actually in the moment. So let's move on. Today we have LeetCode binary search tree. So do you know what is binary tree or binary search tree? Just binary tree. I hope you do, guys, because today we are going to solve a lot of, like, not a lot of 3 questions, but all of them are related to the binary tree. So binary tree is a subset of graphs in the sense that it has nodes, it has connections between nodes. Invariant here is that there are only 2 connections from the parent to the child. So parent has only 2 childs, left and right. And yeah, there is no connection from child to parent, only from the parent to child, kind of like linked list. that's pretty much all you need to know to solve today's questions. And there are a bunch of traversals, algorithms for that. Yes. And first question, maximum depth of binary tree. So given the root of binary tree, return its maximum depth. So in this case, the depth is the longest path from the root to the leaf. Leaf is the node that doesn't have any parent. Oh, sorry, that doesn't have any children. For example, in this case, let me take a screenshot. So in this code, in this case, our leaves are these nodes because they don't have parents, so they have nulls here. And the maximum depth is pretty much the longest path from the root to the leaf, like this, or this. So how are we gonna know it? We can run basic depth first search, or depth first traversal, when we just recursively visiting all the nodes up until we visit the leaf. And we also maintain the depth variable alongside. So at this point, when my function is on this node, I would know that I already traversed this node and this node. So it means at this node, my depth is 3, right? This is pretty much easy question. Let me actually switch to, yes. I'm Vim Motion enjoyer, so yeah, we are coding here. So first, be prepared to a lot of recursive functions because most binary tree and in general tree LeetCode questions, they involve recursion. So just get used to it. So we are checking if root is null. Then we just return 0, because if there is no root, the depth is 0. And after that, we are checking we are calling 2 recursive calls to the left node and to the right node, and then taking maximum of them. Because we should know just the maximum depth. So it can be on the right subtree or on the left subtree. We don't know yet, so we're calling both of them and just check the maximum. So maximum and max depth root left and max depth root right. Exactly. And then what we're gonna return, because this depth that is returned, it's the depth of the subtrees, but we also should include to this depth our current node. So we are returning it like that, depth plus 1, sorry, depth plus 1. And this should be the solution. Exactly. Good. Pretty much easy, just basics, recursive traversal. Let's go to the next one. Okay, leaf similar. So this is another easy problem. Yeah, let's analyze it. So we have the 2 trees with the root 1 is 3, 1 and root 2 has 3, 2. And they have leaf nodes, right? Some of the nodes are leaves, apparently. And what we should check is basically that these trees have the same sequence of the leaves. Yes, and we should check them in this order, from left to the right. So 6, 7, 4, 9, 8. If another tree has the same leaves, in the sense that 6, 7, 4, 9, 8, it does not matter what is happening on the parent nodes. It does not matter at all. Here, instead of 5, it can be 8, whatever. Until this invariant is true, we can return true. Yeah, this is pretty good example. Pretty good example. So you see that like parents are actually pretty different, but these trees has similar, like they are leaf similar. So how are we gonna check that they are leaf similar? So first of all, for sure, our subtask should be, our micro task, should be somehow to get these leaf nodes in the proper order from the left to the right, and then get it from the right tree as well, and then just basically compare them. As easy as that. So how are we gonna do it? How are we gonna ensure the order, for example? So trees have different traversals, and we're just gonna always traverse first the left node and then the right node, and that's it. This way we're gonna ensure that our order will be from the left to the right. As simple as that. Let's first create this traversal function. So get leaves, for example, let's call this function as this. It has node and it has list. List is just an array or array list, whatever it is in your language, where we're gonna push our leaves while we are traversing them. And then as output, we would have two lists, and we just compare list index by index. As simple as that. If the node is null, we just return, we don't have anything to process. If this node is leaf, how are we gonna check if node is leaf? It does not have both left and right nodes. Exactly. Then we pushing this value to the list and recursively calling get leaves node left and recursively calling leaves node right. This is the function that will populate our list with leaf nodes from the left to right. And now the only stuff we should do is basically to get this array from left tree, from right tree, and then compare these arrays. First of all, list 1, list 2. Now we are calling this function for root 1, list 1. We're calling this function for list 2 as well. And now first we check, kind of slight optimization, first we check that list 1 length should be equal to list 2 length. If they are not, we return false straight away, because if some of the trees has additional leaf, it means like however we compare them, they are not equal, right? And then just if they have the same size, just index-based comparing, as simple as that. Let's check. Oh yeah, sorry. I forgot to pass the list as a parameter here. So it is undefined for the subsequent calls. Exactly. All is correct. Easy question, easy solution, right? Yeah, don't be afraid about this 21% because it's so quick in test cases that if it's 2 milliseconds, it's like way below. If you resubmit, it should be around 100. Okay, it's not, whatever. Sorry, I forgot the time complexity for the last one and for this one. I'm sorry, I'm very sorry. So the time complexity for this one, we basically traverse every single node. So the time complexity would be O of n. And the space complexity would be the depths, because our recursive calls, they count for space complexity. So it will be log of n. If the tree is balanced, it will be log of n. If the tree is not balanced, so for example, let me draw somewhere here. So for example, if we have situation like that, so we have tree with only right nodes. So you see this is kind of the linked list. So in this case, our space complexity, because each of these circles, it is function call, right? So in this case, if this amount of nodes is n, our space complexity will be also n. But if the tree is balanced, which means left subtree is equal size with the right subtree, then we will have this situation. I don't know, let's say like this. Then it will be log of n. I hope this is pretty understandable in this case. And for the next, I see some questions from the YouTube. Let's go. I'll answer in a bit, but first, time complexity. Time complexity is the first. So in this case, what is our complexity? We are traversing both of the trees. So we are traversing them fully because we need to reach every single child. It means we will visit every node once in both trees. So this is already O of n1 plus O of n2, and this is for time complexity, right? And then we have our leaves, and leaf can be, I don't know how big leaf size can be, but it's for sure less than number of all nodes that we traverse, so it will not be counted to the time complexity anyway, because like less value, we just skip it, right? So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have so every time on, like, worst case in our case is that all the nodes have both children, right? So let me draw it. Maybe a scale is better. So in our case, what happened with the scale? I'm sorry. Why it's so small? What happened to you? I don't understand what happened to Excalibur. It locked completely. It's kind of like browser C. I don't know how to change the size. I'm very sorry, guys. How to change the size? Like, because Control plus it does not work. Really. Can I somehow send, translate, inspect, view position? Okay. Okay, I think I still can draw whatever. Please. Okay, so I think this is the, yeah. So in case, our worst case is when the parent has all the children. So we have this situation. How we can count how many of these nodes? Well, every time on every node we double the number of children. So in this case it's 1, in this case it's 2, in this case it will be 4. On the next case, like if we draw all of them, it will be, guess how many, 8, then 16, then 32, and so on. Do you see the, like, what is this? This is power of 2, right? So when we have our depths, it depends what is depth, because in this case we have balanced 3, right? But for our depths, yeah, exactly, worst case it's, yeah, it's balanced. Interesting, somebody's also in the office. Anyway, so in this case, when we have depths, interesting, I'm not alone in the office actually at Microsoft today. So this is the depths, and 2 to the power of the depths basically. So how it is calculated? In case we have depths, like how many layers? 1, 2, 3, 4. 4 layers, right? It will be 2 to the power of 4. 2 to the power of 4 is 16. Exactly. This is our value. Добрый вечер.
Ja was znam, go.
It was a security guy. And he knows me. Yeah, so this is 2 to the power of depths, pretty much. And we basically don't care about this because it will be less than n for sure. It will be less than n. So we can basically skip it. Where am I? Yes, here. So it should be plus all 2 to the power of depths, which can be arbitrarily actually, but this is worst case, and it is for sure less than O1, so we basically skip this. And in the end, it will be just these two guys for the time complexity. For the space complexity, it is, so for traversing, for the getLeaves function, we're traversing maximum the depths as well. So since we have recursive calls depths times, it's of depths. And also we are collecting the list of leaf nodes, so it's again this weight value plus 2 to the depths, right? Well, wait a minute. No, it's not actually exponential. What the hell I'm talking about? No, it's not. Okay, anyway. I have some, I think, questions in the stream, right? How did you study English? Well, apparently very poorly, as I don't speak well. People can hear my accent, so. But how I studied, it was uni time, so I was preparing for English exams a couple of times. Then I had internal courses in my company. Yeah, and that's how I studied. Now I'm pretty much mostly in the English speaking environment. That's how. Can you move yes window a bit to the left because can't see what you're writing? Oh sorry, this is my bad. This is completely my bad. Yes, I'm sorry. It was very bad. I'm sorry. Yeah, I forgot that. Also, we should include the chat. I was sitting without chat all this time. It's crazy. Okay. A bit of fail, but yeah. Good. I think this one we are done with. Yes, yes. So let's move on to the next one. It's count good nodes in binary tree. This is already a medium question. So yeah, this is already a medium question. Let's move this guy out. Good. So count good nodes in binary tree. Given binary tree root and node x in the tree is now good if in the path from root to x there are no nodes with value greater than x. This takes some time to parse, I understand. So let me a bit explain visually, because visual explanation works for me very well usually. So yeah. So node x in the tree is named good if the path from root to x there are no nodes with value greater than x. So let's check tree. Tree is always the good node because from the root to tree there is no nodes with value greater than 3, right? Then let's check 4. Well, this is the root and 4 is our child node. 4 is definitely greater than 3. So it is good node as well. Let's check 5 as well. So 5, from the 3 to 5, we have only nodes that are less than 5. We have 4, which is less than 5, and we have 3, which is less than 5. So all of these are good nodes. Let's now check left sub tree. We already face 1, and for 1, if it's our node x, we have 3, which is greater than 1. So, oh sorry, greater than, yeah. So 1 is less than 3, and it means it's not a good node, so it's not marked as blue. But then we move to the 3, and 3 is bigger or equal to 3, which is root, because we are exploring all paths, right? And it's bigger than or equal than 1. So it is good node. Now, how are we gonna implement this? So we're gonna traverse the tree, of course. We're gonna traverse tree a lot of times today. Today we are only traversing the trees. And what we're gonna maintain is we're gonna maintain the maximum value that we currently faced. So in case we go from 3 to 4, we know that 4, like this node x, let's say we don't know it's 4, it should be x should be more or equal than 3, which is previous max number. So maximum equals to 3. Okay, this is true. Now we're moving here to the 5, but now this node x, it should be greater or equal than 4, than previously traversed node. Why? Well, because in case, let me draw some a bit more easier to understand example. Let's say we have 3, then we have 7, and then we have 5. In this case, is the 5 a good node? Well, no, 5 is not a good node, because from the 3 all the way down to the 5, there is node 7, which is greater than 5, so which makes it not good node. So to keep the invariant, we should maintain max value all the time we see some good node. We should maintain the maximum value to the current node. So basically, when we traverse here, we check that in our case 7 is our x, that x is more than or equal 3, which is true because 7 more equal than 3. Yeah, it's visible, good. And then when we move here, we should compare it not to 3, but we should compare to 7. So let's say this is our x at the moment, so x should be more or equal than 7, which is not the case, because 5 is not greater or equal to 7, which makes it not good node. So yeah, I don't know. This is the way. Let's create our traversal function. So let's name it something like good node. This is our currently traverse node and maximum value that we are doing so far, and we are starting. Yeah, sure. Here we are. Yeah, so let's define our function. And we just starting as this. If not root, we return 0. Of course, it's default check, and we then just returning our call to our inner function, which is root and our current root value. In this case, it will be 3. We are starting with this node and value 3 as a maximum value. Then here, what is going on here? Default check again. This function is supposed to return the number of good nodes in the subtree of node. As simple as that. Then let's define our good nodes number. If node value, our current value, bigger or equal to our max value, this is definitely a good node, and we increasing the number, and we are resetting our max value to node value, to current value. Now what we're gonna do, we're gonna check how many good nodes in the left subtree. It's current max value. Max value. And same for the right. And then we're gonna return left plus right, all the good nodes from the subtrees plus whether the current node is good or not. So yeah, our num. That's it. It actually should work, I suppose. Good. Regarding the time complexity, again, we are visiting every node only once. So for the time complexity, it's O(n). For the space complexity, it depends whether 3 is balanced or not. If 3 is not balanced, it's O(n). If 3 is balanced, it's log n. So yes, pretty much, as simple as that. So yeah, I think for now we are done with LeetCode because it took already enough time. So now what we're gonna change to, we're gonna change for the system design, which is pretty interesting question. I'm a bit excited about it. So the question is about not URL shortener, but yeah, this guy. Let me remove all this trash. Yeah, we're gonna do a system design of unique number generator, which is highly scalable, so we cannot afford only one node, and highly reliable, which is also we cannot afford one node. Until that, I think let's have a bit of break. So this is done, this is done, this is going to be done, but I'm gonna take some break, maybe 5 minutes or something like that. Yeah, so see you in 5 minutes. Okay, I'm back. So I would like to get back to our analysis of space complexity because, yeah, this one is pretty interesting regarding the, not this one, the next. So how much space the tree has in leaf nodes. So let's try to do the worst case complexity, because this one is interesting one, and I kind of thought about it on my way back. So how we can do it? Like, I'm not the best in math, right? I'm pretty poor in a way. So let's say our worst case, for sure, the worst case for us is when we have full binary tree. Full binary tree is when all the nodes have both children. So let's say we have this case. Here, and then two like that. So we have one layer, second, third, and fourth. So I'm stating, so let's say h is our height, you know for sure, and n is number of all nodes. So I'm stating that the number of these children is 2 times height minus 1. Let's kind of prove it in case your interviewer is asking that, because this can be quite important. So this is our space complexity. We for sure can say that the number of all nodes here is 2 to the height, because yeah, we can just, I don't know, count them. We have 4 layers, which is equal to 2 to the power of 4, which is 16. Check it out. 1, 2, 3, 4, 5, 6, 7, 8, plus 4, 12, plus 2, 14. Well, almost 16. Because every time we are doubling, right? So in this case we have 1, then we have 2, then here we have 4, then here we have 8, and basically so on. So yeah, due to this fact, let's also state the following. We see that for 4 layers, for 4-layered binary tree, our leaf nodes count is 8. But what if we have 5th layer, right? So every of these guys also have 2 children. We can kind of calculate it, right, from this layer. So if the last layer here has 8 nodes, the next layer will have 8 times 2, which is gonna be 16. And so on. In case we have 6 layer of the nodes, previous layer was 16, the 6th layer would have 16 times 2 equals 32. So for 6 layers, it's 2 times 2 to the power of 5. So this way you kind of can prove it. It's not formal mathematical proof actually, but it is like something that interviewer will be convinced with. So our space in this case is this guy, just to prove it. Okay, now we are fully moving to the Xcali draw, and we're gonna do our unique number generator. This is a very interesting question, and let me try to start drawing something. Like what options do we have? Our functional requirements are generates unique number, cannot generate number it previously generated. Let's also state that it should be monotonically increasing. So it means that if previous number was n, if previous number was n, then the next number should be like, okay, if previous number was n1, and the next number is n2, and next number is n3, we should ensure that n1 is less than n2 and less than n3. This is monotonically our monotonic functional requirement. How we can do it in a spatially distributed environment? So first of all, on every system design, maybe the good way to approach the system design would be okay, this is how I want to do it. Yes, exactly. So maybe the good way of approaching any system design would be first to try to do something on a low scale. So let's say we don't have many users. What are our options? So first option for us would be just to have some, I don't know, database with auto-incrementing key. Yeah, let's draw it a bit like this. Yeah, with auto-incrementing key. Let's say you have some SQL, Postgres, MySQL, whatever. In this case, your database kind of ensures through the internal mechanisms that this environment would be true. So our n1 is less than n2 and less than n3. They're all sequentially increasing, you know, everything is good basically, everything is good. Also, it kind of fulfills the problem with the, if the database goes down, yeah, you will not be able to generate new numbers, but at least your previous numbers are not lost, which is very good. For the same purpose, we can use cache. So it is faster, so db/cache. So Redis has atomic increment, so you can pretty much use Redis for that, and it will be faster than database, I suppose. This is second approach, or it's kind of subset of the first approach, right? What else? What are our other approaches? Like, it's good, but in this case we have single node, and single node is single point of failure. This is first concern. Second concern, it does not scale well, because if you have more requests than this database can survive, or that your bandwidth is already overused, you got throttled and your application is not working, right? So this is kind of bad. You cannot stand single node. It will not fulfill highly scalable 1 million per second. However, maybe 1 million per second it can survive, but like if we are talking about dozens of millions, then yeah, it's a problem. But good database, good, which is well vertically scaled, it can survive 1 million requests per second for sure, without any problem at all. So yeah, does our stream running? Yes, good. So we clearly see that like one node can pretty much fulfill our functional requirements, but it cannot fulfill our non-functional requirements, and this is when the interesting stuff starts to happen. Sorry. Now, how we can do it for the distributed environment? So let's say, can we have two databases or two caches? Sorry. So let's say we have, I'll draw just one database, and then copy paste it. Let's say we have two databases. Will it work in this case? So this is, or it's cache. Like let's say it's storage 1 and storage 2. You can use like database without increment ID, or you can use I don't know, so atomic increment in any of the distributed cache. If we have these two instances, what is the problem right now? The problem is that they cannot sync between each other. like they can sync in a way, but they cannot sync in a way to not decrease our performance. Like there is stuff like two-phase locking for the distributed transaction, for example, but this is slow as fuck and no one actually uses it, all right? So in this case, let's say it's our cache and we are using incrementing approach. So we have our counter equals to 1, and here we have it also equals to 1. And it is already a problem because these two would generate same sequences, 1, 2, 3, and this will generate also 1, 2, 3, and so on. And it breaks our functional requirement because the numbers are not unique, however they are monotonic, which is bad. How we can overcome this problem? Maybe we can start with different ranges. So let's say we can assign to every storage the value from which it will start. So in this case it will not be 1. Instead of 1 it will be let's say this guy starts with 1, but this guy starts with, let's say, 10,000. Now it kinda, for some time, it will fulfill our all requirements because this will generate 2, 3, 4, so on, and this guy will generate 10,001, 10,002, and so on. And they are not overlapping in a sense. The problem will be when the sequence of storage 1 will approach to 10,000. So we have 9,999. Next number will be 10,000, which was already used by this storage. So we need kind of not coordination in this case. We should forbid this node to use the ranges starting from 10,000, right? And it is kind of hard and complicated in a sense, but this is not even the like the main drawback of this approach. The main drawback in this approach is that most probably we want to start our IDs from the 1, 2, 3, 4, and so on. So let's say I'm starting my application, I'm starting requesting the unique ID, and all of these requests should go here because I don't want ID starting from 10,000. So basically this range partitioning does not help us in the sense that it's not monotonically increasing. Like it is monotonically increasing, but it is again a single point of failure. If this database goes down, yeah, we kind of can promote this database to start handling numbers from 1 to and so on, but we have a lot of problems with this. Because how are we going to remember when do we stop here? Like let's say the last one here was 5. We cannot start from 1 because 1 was already issued, right? So we need again like communication, a bunch of problems with this. So this solution is not scalable, of course, for sure. How else we can do it? Like what are our other approaches? Another approach would be maybe to, instead of going to one database and get IDs from 1 to 3, 4, and so on, we might use like our client ID, whoever it is, maybe it's server, maybe it's some front end, does not matter for us. And we're using modulo of number of nodes, which is the worst, I think the worst. This is the worst partitioning method, but whatever. Number of nodes, and we would be going evenly. One time with 50% chance we're gonna go here, and 50% chance we're gonna go to S2. Then our sequence that we are going to issue would be something like that. So 1, 10,000, sorry, 10,001, 2, 10,002, and so on. It is not monotonic. right? But now it's kind of evenly distributed. If we keep adding more nodes and assigning ranges, and we go just randomly to any of them, it will work. It will work okay, actually. But we still do not fulfill our requirement with monotonically increasing invariant. So yeah, instead of ranges, actually we can go to real-world implementation of what we are just talking about. Oh, sorry. And real-world implementation in this case is I don't really please. Yeah, let me find it's yes, it's this one. Let me show you. So there is such thing called flickr.com. I don't know whether I pronounced it correctly or not. So these guys also had problem. This is, I don't know, some cloud for media, for photos and for videos, I guess. And they also had the problem. They wanted auto-incrementing IDs. And they came to the conclusion that, okay, auto-increment on the level of database can work, but then we have only one database, which is single point of failure, right? So it will not work. Exactly, you can make cross multiple databases, exactly. So what they came up with instead, they have so they created two ticket servers, and what they do, they are just issuing odd numbers and even numbers. How it works, that this guy gonna issue 1, 3, 5, 7, 9, and this guy gonna issue 2, 4, 6, 8. And you can scale it even more if you want, for example, 4 storages. It can be 1, 5, 10, then 2, 6, 11, then 3, 7, 12. You got the idea, so you're just offsetting them. And this is what they implemented, and it kind of already proven that it's gonna work. And they are doing round robin between two servers to load the balance and deal with downtime. Yes. I think we have a few 100,000 more odd number objects than evenly numbered objects. So this is not monotonically increasing sequence, as you can see, because it also can generate us like 1, then 3, then 2, then 4, like completely random stuff. So it's not monotonically increasing. If you don't have monotonically increasing requirement, it fits you well. The only one problem is, you would need to increment something more sophisticated, most probably, because this solution is not scalable. If you want to add additional database here called S3 or cache, whatever, you're kind of breaking your mechanism, because your offset, you're starting from 0 for both, and you keep offset here S2. S2, and here offset is 2 as well. No, sorry, you're gonna start from 1. This is what they claimed. So auto increment 2, so you're starting from 2, So auto, let me explain how it works. So ticket server 1, it does the offset 1 for every ID. And this guy does offset 2 for every ID. Okay. Yeah, so in case you're adding one more, you're gonna get overlapping. Actually, I don't understand what does it mean auto increment. Provision ID with single point failure, issue high availability. Locking will kill performance. Yeah, that's for sure. Middle and odds. Okay, so with this one, what they are doing, we don't care about implementation, we care about result. What they are doing that, yeah, one database is issuing odd numbers, another database is issuing even numbers. In case you want to scale, you're kinda done and cooked, because like, what you gonna tell to this database? Which numbers it should issue? All the number field or area is already occupied. If you start from 1, if you're gonna increment by 3, it does not matter. Your numbers would be 1, then 2, 3, 4, then 4, which is already occupied by this guy. Then 8, 5, 6, 7, then 7, which is gonna be occupied by this guy. So you have overlapping, you are lost already. So this is like, this solution is not quite flexible actually. It's not quite flexible. The North Star in this case would be something called snowflake IDs. This is the already production tested solution that was actually designed by Twitter, I think now X, and also by other things like Discord, Instagram. They are all using the same approach. So this is kind of the approach of generating the unique IDs that was used in UUID version 1. So how did they do that? Yeah, GUID, how I call it. Not only me, but whatever. So what is the format of UUID version 1? The format was that first pack was occupied by timestamp. We are talking about bits. So these are 0101 bits, whatever. Then after that, there was some machine ID. And after that, it was some random value, pretty much. And you just put these bits together into 64 bits, so you can have one long number, 2 to the power of 64. And yeah, in this case, you can guarantee monotonically increasing unique number generated, because every single second, or sorry, it's millisecond precise. So every single millisecond for every single machine, you're gonna get exactly unique timestamp. If it happens that one machine is issuing the ID within the same millisecond, you're using these random bits. I think it's 12 bits for random suffix that minimizes the probability that even for 1 millisecond for the same machine, you're getting 2 same IDs. It minimizes it. Like in a nutshell, Snowflake ID is exactly the same thing. So they have timestamp, first bits. Then they have machine ID for the server. In case like 2 servers generate exactly the ID in exactly same millisecond, or due to time skew. And then machine sequence number, which is atomically incrementing number as well. What is the benefit of this Snowflake ID approach is that first, you don't have to store anything. You don't have storages at all. You don't need them, because this guy can be generated purely from the computes, from your API, which is pretty good. And I think this is already a good benefit. Also, it's pretty much the best in terms of tolerating the outages, because in case you're losing your API node, okay, you can spin a bunch of more API nodes and they will be working exactly the same algorithm, generating again unique numbers. So with this algorithm, how it will actually work, that you would have like bunch of load balancers deployed, right? And your client gonna talk to your load balancers. You have bunch of APIs that only busy with this generating of these numbers. Every machine has, or every this node, they has machine ID, which is unique. So let's say this one has 3, 2, 1. It guarantees uniqueness. And basically your load balancers are talking to these APIs whenever they want to issue the new ID, new unique ID. And you as a client just calling one of the load balancer. That's it. It's well scaled. You can scale it as much as possible. It's fault tolerant, because if you remove one node, you can replace it with another node, no problem at all. It doesn't have state, so it's completely stateless, so pretty beneficial one. Most probably this is how, and this is why such big companies like Twitter, Discord, and Instagram are using this algorithm. Yeah, this solution we will implement in .NET, I think in the next session. But there is another, this is kind of follow-up now, because this is what we're gonna do, like nothing else. This approach also can be implemented, but I don't see real benefits of doing that, to be honest, so far. Another thing that I've heard of is, so I think I've heard that some company asked one guy on the interview about this. So let's say we have one ticket server. This is ticket approach or something like this. This is ticket server. And let's say we can pre-compute the ranges of unique IDs beforehand. So this guy generates, I don't know, batches of unique IDs, and it claims that once this batch is returned to some node, it will not be returned to any other node. So we kind of ensure it will not generate duplicated IDs. So meantime, it computes these guys. It can be using auto-increment approach from databases. It can be using caching. It can be using in-memory even. Whatever it is, doesn't matter. And whenever there is some client that asks for unique ID, instead of one ID, this guy issues you a whole bunch. So you have this batch, and you locally can process this batch one by one up until the batch is over. Once the batch is over, you go against this second request, and this guy serves you, oh sorry, this is not correct. This is not correct. Yeah, it should be like that. And 20K. So once you're done with this batch, for example, you requested 1 to 10,000, you already used it, then you go to this service again, and it requests you the batch from 10,001 to 20K. And you're using this batch. There are also multiple problems with this. Maybe we will even implement this as well, like in .NET. But what are the problems? So first one that I see, let's say the node that asked this batch, it went down, right? So if this batch is not stored in memory, we kind of lost a lot of unique IDs. This is the first problem. And how it will be working, right? Like, what is our end goal? We want some API to which we can send request and which give us only one single unique ID. So in this case, we don't want to break this API. So most probably we would need to put our workers. So let's say this is ticket server. We have a bunch of nodes, which are our workers. We can distribute them. Each of nodes gets this range. I don't know, from A to B, let's be simpler a bit. From B to C, from C to D, from D to E. And now we still have the same exactly problem that we had before. First problem, that most probably we want actually first to start with the lowest numbers. Like it can be the requirement that we want to start from 1 up to 10,000 before we start with 10,000, 20,000 and so on. So if we want monotonically increasing IDs, it is still single point of failures because all the requests initially would go to this one node. It cannot go down because ticket server already issued this range, right? Maybe we would need to store this range in some database near the node, and all this bunch of problems we would have here. If we use hashing, for example, and we evenly distribute load between the nodes, then in this case we lose monotony, how to say it, like we use invariant of being monotonically increasing numbers, because in this case one number can go from this node and other number can go from this node, and we will have like 1, 10,000, 5, 6, 7, then like 7, whatever. It's not monotonically increasing. So the North Star solution would be exactly this guy, which is stateless and does not require any storage, only compute based, easy scalable, easy reliable, all functional and non-functional requirements are fulfilled at the same time. But also there are other approaches like ticket servers with the ranges and modulo operations. There are other approaches like, for example, having nodes to handle odd, even, and so on, modulo and modulo sequences. But this approach is either not scalable or it does not guarantee monotonicity, or I don't know whether I can say it. So the sequence is not monotonically increasing. Yeah, so this is the trait in these two cases. But if you don't want monotonically increasing number, which we actually don't want in URL shortener, what we actually need is just the number to be unique. And with this approach, it is guaranteed, as well as with this approach. But ticket server approach also has one drawback, that it can be, it can lose the data, right? If you assign the range to some node, it can lose the data. But yeah, actually we can store it and it will not be lost. So yeah, these are three approaches. We're gonna first implement this guy. And also what I like is this ticket server approach, because it's kind of scalable as well. We can add new nodes and ask the ticket server to populate new range, right? And it will work. It's pretty scalable. If we are using hashing for partitioning, it is also fault tolerant, because if this node is down, there are still a bunch of nodes that are available. If we want monotonically increasing sequence, this solution doesn't work. This solution doesn't work as well. So these are my findings, and I think in the next stream we're gonna start implementing it. Maybe I'll find out the solution is not actually working, then we will redesign. But this is the North Star. Remember, Snowflake, like ticket, Snowflake ID generation. Production confirmed working solution for unique and monotonically increasing IDs generation. Good. So far I think we are done, and now the last point in our stream is real interview questions. Last time we checked mutex versus monitor versus semaphore. Now let's take a couple of questions as well. For example, concurrency handling in entity framework. This is purely .NET question, so I will not stay here for a long time. But basically, entity framework is pretty much ORM, right? Object relational mapper or something like that. So this is just a wrapper over your database for how you can easily and conveniently use your classes and objects instead of like tables, like in database, right, in SQL. So usually concurrency handling in entity framework is pretty much the question about concurrency handling in the database in general. So first, what we need to know about concurrency is the isolation levels. There are 4 main isolation levels for database, which is serializable, read committed, snapshot, and read uncommitted. So yeah, read committed, read uncommitted. So this goes actually as a first, then repeatable, read, and then serializable. Shortly explaining, read uncommitted is when you can read data from non-committed transactions that is going on right now. Read committed is when you can read only data that was changed by committed transaction, so no dirty reads. A repeatable read is when you have snapshot of your data in the beginning of your transaction, and whenever you're reading this data, it gets the version that was during the start of the current transaction. And serializable, the most severe and the most the worst pretty much from the performance standpoint is when you have only one thread that is performing the operations over database. So you, in theory, you cannot have concurrency problems. So concurrency handling in Entity Framework. If you have serializable, you don't have to have any concurrency handling mechanism. It's just you have one threaded database. It will execute serially, so one by one. You don't have to worry. If you have repeatable read committed and other isolation levels, then yeah, you might have problems with the concurrency level. So databases usually handle concurrency in 2 ways. So first, it's optimistic concurrency, otherwise called compare and set. This is what Entity Framework, I believe, is using when, let's say, I read row 1 with ID equals 1, and let's say timestamp of change equals 5. Let's say I modify this row, and now I want to write that row back. Row ID equals 2, equals 1, but timestamp, because I modified it, sometime happened, equals 6. The thing is with this optimistic concurrency approach is when we are trying to write, so we are doing some write into blah blah table. I don't really remember the SQL statements, but it should be something like that, right? Or no, it should not be write, I'm sorry, it should be update. For write there is no concurrency, like concurrency is handled during the uniqueness invariants, yes, on constraints, constraints. So update table, then set, I think, I don't remember the syntax, but anyway, what we are claiming is that, let me draw it as well. So we have some row, it has value QWERTY and timestamp equals to 5. We read this value, we perform read, and we want to update it to be row QWERTY2, and timestamp should be timestamp that is higher than current one, let's say this. This is what we want to update. So compare and set approach or optimistic concurrency approach is when on our write we are telling database, please, whenever you try to update this row, check the timestamp with which we read the value. So on read value we have timestamp equals 5, that this timestamp that we read, the database has exactly same timestamp right now. And on database level, it is checked. kind of atomically, and in this case, if another thread modified it to QWERTY4 with timestamp 6 or 7, whatever, so it is not 5. Database will check that 5 is not equals to 6, and it will abort the transaction. So you will get failure on the update with the message like concurrency, like this value, like timestamp is not 5 anymore. So this is how entity framework handles concurrency. Let me double check it. Actually, like usually how you check it, you just go to MSDN. Yeah, optimistic concurrency, exactly. So you have this version, and whenever you're writing, you check that version didn't change. Yeah, version column has changed since the moment we queried it. Exactly. And entity framework has a bunch of stuff to support this optimistic concurrency. Yeah, and then how do you resolve? Usually when you get optimistic concurrency issue, you just retry. If you have high probability of conflicts over your operations in database, then what is actually better, instead of keep retrying all the time, it's better to lock the particular row, update it like in single-threaded manner, and then basically move on. Because there is this trade-off. If you have like a lot of updates, most probably most of them will fail due to concurrency, and they will be retried, which generates even more load. So x2, x3 load, it depends how you are retrying, right? If you have exponential backoff and exponential retry, let's say 1000 APIs or nodes try to write the same exactly row, like one will be succeeded and 999 will fail due to optimistic concurrency. They will be retried once, then retried again for this who failed, and it will generate like much more load than actually you initially kind of put to this database. So instead, maybe it's better to have locking, and performance-wise, locking can be even better than optimistic concurrency in case you have high load or high ratio of conflicts. This is about concurrency handling in entity framework. Now to list versus to array. I remember I was doing some benchmarks. Basically, there is no difference under hood, I guess, because how it works in the .NET, that our list is actually resizable array. So it has amortized time constant for adding, but it's still a static array. So when you're performing to array or to list over enumerable, it's pretty much the same, but to list, I think it generates a bit additional fields, so this should work pretty much the same. Now these guys, this is pretty interesting. This is async await call whenever you have a method that returns task. So potentially it's concurrent method. We can basically wait for the result. We can call getAwaiter getResult and result. So I don't really remember what will fire what. Let me actually open my Visual Studio and find some example. So let's say this is our method, right? Boom, boom, boom. Yeah. The thing is that instead of await, how you can wait until this method is completed is the following. So you can do result. Oh, sorry. How to perform actually result? I don't even know. Okay, so better thing. If I got this question in interview and I don't know answer, for sure I would just yes, I would just Google. So wait, yeah, general difference is all of these, they are not async actually. They are forcing your thread to wait until async operation is done, which is kind of already bad because you want to free your thread when you're doing input-output async operation, for example. So it's blocking calling thread until task is completed, exactly. And throws exception aggregated if it fails. Okay, getAwaiter getResult. I think getAwaiter is used in async state machine, so it's kind of the most natural way how to do it. It's a bit safer. It throws actual exception instead of aggregated exception, which you usually want to. GPT recommends it over. Yes, where synchronous waiting is unavoidable. Exactly. Yeah, that's it. And yeah, and this thing, it is used in async state machine, which is one more point to use it. And similar to wait, but blocks calling thread until task completes. If the task fails, it throws aggregate exception. So pretty much wait and result are equally bad, and getAwaiter getResult is a bit better since it throws actual exception. But the better and the best approach is to always use a async await keyword. Then you don't block your thread if it's input-output operation. If it's compute operation, it doesn't matter. Okay. I think this is where we stop at this point. I think we streamed already enough. I don't see any actually more questions at the moment. So we covered some of this. Yes, that's it. So I think we're pretty much done for now. Thank you for being with me. It was pretty cool stream. A bit fast, I think, but I just got from sick leave, so it's okay. Yeah, I think we are done. Thank you for being with me and see you around. Bye bye.